Okay, let's see. Let's see what numbers we need to do. 2, number 2. You ready? Here we go. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, plus or minus 3/2, plus or minus 1/4, plus or minus 3/4.
Huh? I did way too much work for that problem.
The actual zeros, so the instructions on 2 through whatever it is, 1 through 8, say to list all the possible ones. So those are the possible ones. And then the actual zeros are 6, 1/2, and negative 1/2. Right? And then 6, all the possible ones are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, plus or minus 32, excuse me, plus or minus 64, plus or minus 1/2, plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 8/3, plus or minus 16/3, plus or minus 32/3, plus or minus 64/3, plus or minus 1/6, plus or minus 1/9, plus or minus 2/9, plus or minus 4/9, plus or minus 8/9, plus or minus 16/9, plus or minus 32/9, plus or minus 64/9, plus or minus 1/18, and the actual zeros are negative 4/3, well, the rational ones anyway, negative 4/3 and 2/3. Aren't you glad you had a calculator to we'd figure out where to go instead of having to try however many things I just read? Because that would have been obnoxious. Did you? Is that the one? Is that the one that you did a bunch on? Well, you put in your time.
I started doing it like on an expo board so that I could just do it on expo, then erase it, and then just write the right one down on paper. To save space.
All right. Number 10. So for the bounds, you could have you might have put something slightly different, but negative 3 and 10 to 10, and the zeros are 6, negative 2, 1, and 4. Wait. I'm totally reading the wrong problem. That is not 10. Where is 10? 10. Just kidding. Number 10 is negative 1. 3, negative 2. Negative 2 has a multiplicity of 2. Number 14 is, excuse me, negative 3, 8, 2, and negative 1. Number 20 is right here. So this is where we got bounds. Your bounds could be slightly different as long as they're not in between these. Negative 6 to 4 is what they have. And then the zeros are 2, negative 1, 1, and negative 4. Number 24, bounds negative 3 to 5. And then the zeros are 1 with a multiplicity of 2, and negative 2 with a multiplicity of 2 and 3. Number 26, it has one, or it can have 1 positive zero, 2 or 0 negative zeros. And 28 be 2 or 0 positive zeros and 2 or 0 negative zeros. 30 is 3 or 1 positive zeros and 2 or 0 negative zeros.
Do you want the chart for this?
You can do the full chart. That's totally fine. It only asks for the positive and negative ones, it's the real ones specifically. But yeah, it wouldn't be a bad idea to do the chart to keep that habit and knowledge in your brain. Number 32. Yeah, we did.
We did all the way through 48. There was like 32, 36, 40, 42, 46, 48.
That's all right. 32 is f of x equals x to the 4th minus 4x cubed minus 23x squared plus 54x plus 72. 36 is f of x equals x to the 4th minus 4x cubed minus 41x squared plus 80x plus 420. Number 40 is f of x equals x to the 4th minus 12x cubed plus 74x squared minus 172x plus 41. And 42 is somewhere else. Yep, somewhere way else. Give me a second. Hello? Hello again. 2, 4, keep going. 42a is g of x equals x minus 4 times x minus 3 times x plus 2 squared. 42b is apparently the same thing for some reason.
Because one of them you're supposed to have it with the linear and the like.
Oh, right, and it's,
quadratic,
okay,
there's
gotcha. But there's no complex ones. 42c is 4, 3, negative 2 with a multiplicity of 2. 46a is, excuse me, 4x plus 5 times x plus 3 times x squared minus 8x plus 41. 46b is 4x, f of x equals 4x plus 5 times x plus 3 times x minus 4 plus 5i times x minus 4 minus 5i. And 46c is negative 5/4, negative 3, 4 plus 5i, and 4 minus 5i. You, on 4c, you can, it would be totally fine to combine that into 4 plus or minus 5i. That would be totally acceptable. 48, g of x equals x plus the square root of 5 times x minus the square root of 5 times x squared plus 36. 48b is x plus the square root of 5 times x minus the square root of 5 times x plus 6i times x minus 6i. And 48c is square root of 5, negative square root of 5, and 6i and negative 6i. And same thing goes there. If you put plus or minus square root of 5 and plus or minus 6i, that would be totally fine and acceptable. Now, what questions do we have from this guy? 36 and what? Yes, I can. 20 is negative 6 to 4, and 2, negative 1, 1, negative 4. 36. Oh yeah, square root stuffs. Okay, so 36, we're supposed to write a polynomial function of least degree that has the real coefficient, with real coefficient standard form that has the zeros. There we go. Plus or minus 2 times the square root of 5 and where am I? 3, negative 3 and 7. Okay. So, what should we do?
Okay, so to try to do the 2 squared root negative 5, I wrote it as x squared minus 20 and x squared plus 20 for the two things.
Oh, I see. Right, yeah, I'm following. It's even more straightforward than that. I understand where your brain was, and it's lovely, but it's even simpler than that. X equals x plus 2 times the square root of 5 times x minus 2 times the square root of 5. X plus 3 and x minus 7.
Oh boy. And is that it?
That's it for one part of it. What all are we supposed to do? Is this the?
You're supposed to make it into a full
Oh yeah. Now we've got to uglify it.
I hate that.
Right? So we get busy distributing. Here we go.
Is there a way to do this in your calculator?
Depends.
Because I have an equations app on my calculator.
That's not doing this because you would want an expansion function. You could I don't know if built in on that calculator it exists, but you could build a Python program to put on that thing that would do it, but you'd have to build the program or maybe find someone else that built one. But I'm going to want you to see your work, so you know, you could do it to check it, for sure. X squared. The inside outside are going to cancel right on this one because it's conjugate, right? So all we care about is the last. So minus 4 times 5, which is where you're 20, right? And then x squared. How badly are y'all going to yell if I just do the inside outside in my head? Y'all going to yell at me?
I'm fine. I have the answer, I think.
I may cry.
Except I was about to do it wrong, so you know, that would have been fun.
I just end up doing it out because I know I'm gonna mess it up if I try to do it in my head.
Yeah, that's wisdom.
A squared plus 2ab.
Yeah, but that only works if they're the same. If it's squared. There's not any shortcut. I just did -7 times x, and then 3 times x, and then -7 plus 3 is -4. So yeah, it's not really a shortcut. It's only a shortcut if it's the thing squared. Minus 20 is what I was going to be writing.
That came from the square root.
So this one, since it's you're multiplying conjugates, the outside and the inside are canceling, right? So it's only the 2 times the square root of 5 squared.
So it gets you 4 times 5, so 20.
Yes.
So, by outside and inside are canceling, can you like underline things that are canceling on the?
So that would be the bottom. Well, actually, no, the way I drew it, it's not. It would be this one and this one, right? Because this one's going to be positive this times x, and this one's going to be negative this times x. So it cancels. And it'll always be true if you're foiling conjugates.
So really, you just have to distribute the +2 to the.
Just this one times this one and this one times that one are all you have to do. Just the
top ones.
yeah. Oh yeah, it is I was right. Yeah, just the top lines. Yeah. I don't know where my brain's at this morning. I keep making dumb mistakes, like all through algebra 2. But we had fun with it. We made it into a thing. It was great. But I kept making little mistakes. I don't know where my brain's at today. Somewhere else. I don't know. All right. So x squared times x squared is x to the 4th, and then minus 4x cubed, and then minus 21x squared minus 20x squared plus 80x, and then plus 400 and something, 20.
Yeah, plus 120.
Then this one and this one.
Yes.
Oh, yeah, you said, I thought you said times, and I got real confused. Like, did I make a mistake? Yes, okay, yes, that is what we will do. You are accurate. X to the 4th minus 4x cubed minus 41x squared plus 80x plus 420. What?
Oh, you just combine like, okay.
Yeah, just combine like terms. All right, what else?
What page is this on?
It's on page 127.
Oh, I'm just writing the first one.
40?
40? Sure.
This is the one that I worked out on. No, this was the one that, yeah, this is one of the ones that I worked out on. So I was just like, I know what I'm supposed to do. And I showed it to my dad, and he was like, oh, I haven't touched this in like 20 years.
Right, right.
The
Yeah.
engineer did not help.
Yeah, engineers are not going to be messing with complex numbers much. Unless possibly they're like, well, no, even then that wouldn't be the engineers. But I was thinking some high-level meteorologists maybe, but that would still be more of a physicist than an engineer, so, you know.
My only older sibling didn't even take calculus, so I'm just on my own here.
Yep, yep. Just on your own.
And I have an engineer who's not helpful in any circumstance. If you ask him a question, like, for example, what is 4 plus 4? He'll tell you the story of how addition works and how addition was invented before he tells you what 4 plus 4 is.
But isn't that so fun? You get to hear about Captain Cheat.
I don't want to hear about Captain Cheat. I want to get all this learn
All
how
right,
to do math.
40. Interesting. I wonder if 40 is a typo. Oh, no, I see. It's just, yeah, because, yeah. No, it's not really a typo. It's just written incomplete because that's how they write those. Okay, same instructions, but we're doing these zeros. 2 plus or minus square root of 3 and 4 plus 5i.
Where's it?
What are y'all doing? Oh, hey, would you put some water in this? Okay. Here we go. F of x equals 2 plus square root of 3 times 2 minus square root of 3 times 4 plus 5i times 4 minus 5i. Complex conjugates.
How do you get the 4 minus 5i?
Complex conjugates.
They forgot to put it there.
Well, it's not really a forgot. It's just like a shortcut way of, because they have it like I think it'd be better to write it out. But that is kind of the normal way to do these. Like you go to pretty much any other pre-cal or cal book. Well, this exact kind of thing won't be in a calculus book, but you go to any other pre-cal or algebra 2 book and it's going to be the same way. It's just sometimes engineers are lazy and so are scientists sometimes. I mean, that's just how that works. And so that's kind of the accepted way of doing it, but that's what's happening. And then we got to do a mess. The nice thing about this problem is we got 2 sets of conjugates, so we can throw out a bunch of the FOIL things, right? Because like we just need the first here and the last here, and we need the first here and the last there, right? So we can throw out all the middle bits because they're all going to cancel. Now we can't do that on the next one we do in a minute, but for these 2, that's going to save us some time and trouble, which is handy. So we got 4 minus 3 times 16. I'll go ahead and write this one all the way out. Minus 25i squared.
And then I squared is going to be negative 1.
True.
So then it's going to be 16 plus 20. So is the final answer just 41? Or plus or minus 41?
Did I leave out some x's?
No,
No,
there were no
I
X's.
didn't. There was no x's, but there should have been. Right? Because these are zeros. So let me rewrite this whole thing.
They forgot the X's.
They didn't forget the x's. I just forgot what we were doing, or stopped in the middle of the thing. Okay, try again.
I was confused on why we weren't writing down x's.
Yes.
What X's?
Well, in the function, right? Okay, try again.
So,
F of x equals x plus 2 plus square root of 3 x minus, well, yeah, whatever. Probably not whatever. You might wait on the signs for a second before I double check my sanity. Okay, hold on, time out. Let me double check my brain. Oh yeah, yeah.
We do.
So one lesson 4, and there's 6 lessons. So 7.
Okay, yeah, because the sign flips going from these things, zeros, back into the factored form. So that's why these minuses are happening, yes. And then the pluses and minuses, these ones are because of this, which is also, and these ones are because of the complex conjugate, right? So this is plus and this is minus. All of these outside minuses are because the sign would switch going from roots back into the function.
If you plugged in the factored version of an equation of a function into the graphing calculator, would it come out the same?
Yes, as long as you punch it correctly. But yeah, it will. Okay, now, so I want to clean up a little before foiling, I think. So x minus 2 minus the square root of 3, x minus 2 plus the square root of 3, this is kind of what I was trying to, this is where my brain was trying to think a minute ago. X, and actually, I say that, no, I'm not wrong with myself. Keep going. After what?
That should be correct.
Yeah, I was thinking it is correct. I had a thought that there might be an easier path. And maybe there is. But in my today's mental state, I don't know if I'm going to find it quickly. Okay. Now what? We do a whole bunch of mess, right?
Can we do the first two distributing first, then the second two, and then do the rest of it later?
Yeah. What do you mean?
Like do it in chunks.
Well, you have to do it in like these chunks. Yeah. Yeah, that's what I've been doing.
No, you have what we're gonna do.
Oh, I'm sorry. You're trying to keep me in line here.
You asked.
I did. I'm not yelling about any of it. Some stuff is going to cancel, and if you see where that's going to happen ahead of time, then you can do that. But liable to be an issue. All right, x squared minus 2x plus x times the square root of 3, which is going to poof away in a minute. And then negative 2x plus 4. And then minus 3. That's, oh no. I skipped one. Minus 2 times the square root of 3. And then negative x times the square root of 3. That's where it's poofing away. And minus 2 times the square root of 3. And here's the minus 3. That's the first bit. Let's do a little, I'm going to just clean this up and then write the other one. Does that seem reasonable to everybody? That. And then the x terms will go together, and then these will go together. And these will go together. Squared minus 4x minus 4 times the square root of 3 plus 1. And then the other one is going to be x squared.
Are we gonna have to distribute that into?
Yeah. What?
I never thought there'd be something more tedious than 3x3 problems.
X squared
Nerds in math.
4x. That's gonna this is gonna cancel. I'm just gonna not write it out this time. Deal. This times this and this times that. That makes sense? Sound reasonable? Okay, continuing on. Okay, negative 4x again. And negative 20 I. This is going to probably cancel too, right? Or we did this wrong. And by we, I mean me, I suppose. 20. Yeah, and then the next one would be plus 20i. Yeah, that's going to cancel. Good. Good. That means we did it right. Okay. I'm wondering whether there's something. Did I do something wrong on this first one? I feel like this should have gone away.
Yeah, that should go away.
I made a sign mistake somewhere.
Maybe if you want to look at this mess, figure it out.
Right? It's one of these. One of these should have been positive. The first one was this. This should have been a negative. Ah, yeah, that one should have been. This one should have been positive. Yep. Yep, yep, yep. What was happening?
You're right. Plus 29.
I'm at the last one. Minus, that's going to disappear. That's already did that.
Then negative 5i times.
So positive 25, right?
Yes.
Blap, blap, x squared minus 8x plus 25. And then we've got to do this times this.
Yay, what is it?
And then we get to the answer eventually,
What's the
right?
answer again?
Let's see. This was what number?
40.
40. X to the fourth minus 12x cubed plus 74x squared minus 172x plus 41.
Woohoo, I did it right.
Wahoo.
Okay, 46 and 48, we still have time. Or what do you think?
Can you repeat the answer just kind of?
I can. F of x equals x to the fourth minus 12x cubed plus 74x squared minus 172x plus 41. De nada. All right. 10 and 14. Great. Let's do 10. Okay. Yeah, something different. That sounds fun. Different than this. I gave y'all a nice, fun homework problem, but I ended up shooting myself in the foot because we had to do it in class. All right. Number 10. We're supposed to solve this. X to the fourth minus, is it minus? Plus 2x cubed minus 7x squared minus 20x minus 12 equals 0. Okay. There's one positive real one, negative real ones, x to the fourth minus 2x cubed minus 7x plus 20x minus 12 equals 0. 1, 2, 3. So 3 or 1, negative 1. There are a total of 4. So 1 or 3, 0, 1, 1, 2. Okay, so that's what we're looking for. What can we try?
Let's try 6.
Okay.
We should get the graphic calculator to make this a lot shorter than graphic.
You can. That's totally fine. You can stick this in the graphing calculator and see where it looks like they are and guess from there.
I messed that up every time I tried to do that. So.
Okay. 6.
You try 6.
1, 2, negative 7, negative 20, negative 12. 1, 6, 8, the 40, no, what? 8 times, yeah, 46. 39, some large number. There's like no way this is going to work at this point, right? Okay, what are we going to try now?
Believe, Sean.
Huh?
You can always believe.
I can, but that's going to be gigantic, and minus 20 isn't going to get us anywhere like nearly enough to be 12. What do we want to try now? 2. Great. One, 2, 4, 8, 1, 2, negative 18. No, no good. No dice. What do you want to try now?
Graphing calculator.
Well, pull it out.
Don't tell it.
Oh, well,
Well, I can use that.
it's true. You could. What do we want to try now?
It's only the multiple of 12, right? That can be the possible answers?
Factors, but yes, that's what you meant.
Let's do -1.
Let's do it. Aiden's got a clue over there. He's got his cheater.
Cheater, cheater, pumpkin eater.
1, -1, 1, -1, -8, 8, -12, positive 12. Who'd have thunk it?
Okay. You can also do positive 3.
Also do 12 and 3. All right. 12.
Where did you get the 12? I said positive 3.
Ah, I thought you said you can also do 12 and 3. That's where I got it, from my ears, but they failed me. All right, 1, 3, 4, 12, 4. What?
Are we doing 3?
We're doing 3. 12, 0. We done did it.
And then the other 2 are,
X squared plus 4x plus 4. So -2, multiplicity 2. So -1.
Can you factor once you get down to the
Yes,
thing?
yes, if possible. Or use the quadratic formula or whatever, yeah. Once you get down to a quadratic, you have all those options. And 2, multiplicity 2. Make sense?
Are we just answering questions from class today? Is there no lesson in class today?
Possibly.
Okay, can we do 46? Because I got stuck.
Did you still need the other one, or does this get you with
I'm so sorry,
what you
I completely
needed?
forgot. I was so confused where those numbers came from.
Which ones, girl?
The 2. Why is it there 2?
Because
Hang on, let me
Because when if you factor this, you're just talking about this part.
yeah.
So when we factor this, it factors into x plus 2 times x plus 2.
Okay. Yeah.
Oh, yeah, we factored.
And it's just asking for the zeros is what
It is asking, well, it's asking to solve it, which is the same thing.
Okay.
Yeah, and technically on this one, well, no, actually they wrote it. That's funny. No, they did. No, I see, I follow. Yes. Okay, what, 40 something? 46. I was in the ballpark. 46. This is going to be another tedious one, isn't it? This is we need to graph this, right? Is that the instructions basically? do all the other stuff and then graph it?
I think it's just list all the zeros.
No, we have like
46.
Oh,
The products of linear and your, oh yeah, it's where you, yeah. We gotta factor it and do all the things. Yeah, so we gotta factor it first, and then we gotta factor it more. Kinda, not really. And then we gotta list the zeros. 46, 4x to the fourth. Minus 2x something. I don't know. No.
You're doing 46, right?
We are. Minus 15 x cubed.
Plus 43x squared. Plus 577x. Plus 615.
All right, 577. We love to see it. 615. Okay. So, gotta factor the dang thing. So, what should we do?
Are we doing a
negative 3.
-3?
Sure, sounds fine.
I have 2 of the same thing.
You have 2 of them? Nice, okay. Negative 3 minus 15.
Do we have to, like, when we're doing the problems, do we have to list all of the possible things, like the plus or minus?
Not if the instructions don't say so, which on the test they will. Well, not all the possible, there'll probably be a problem that says list all the possible, like, and that's the only thing you have to do. And then there will be problems where you have to do the chart and all, like, describe them, you know, all the things. All right, here we go. 4, negative 12, negative 27, positive something,
108.
108. 151, yes, I agree with my brain. And then negative 4, yep. 53, and then,
30.
uh-oh.
What? No. Where did I? Okay, so I did negative 5 over 4 first and then did negative 3. Because both of them got me zeros, so I'm not sure what we're missing.
Well, this would be 124, right? So just somebody punch that on the calculator just to double check. 3 times 124, see what happens. Is
No, 372. That's not right.
we can check the other numbers too. There may be something going on. Let's see. The 3 times 27 would be the first one I would be not sure without thinking about it. That's so 27 times 3 isn't 108.
Yeah.
I think that you may have been looking in the wrong place or something. It's 81.
I said 27 times 4, dang it.
Gotcha. Okay, 81, which will shift this over to 124, which is ironically the same as that. I guess that kind of makes sense, actually. And then
And that's the 327.
that's the 320, negative 327, okay? Okay,
372, yeah.
okay, 372.
Oh, numbers aren't
Yeah.
glorious.
They are so glorious.
And then I do the negative
205, and then that probably does give you negative 615. That sounds accurate.
I'm dealing with numbers that are larger than 2 digits. I don't know.
Right, right. Okay, at least there's not like decimals or something. Well, of course, you can't actually do this with decimals, so. Yeah.
Another one is negative 5/4.
Negative 5/4, because of course it is. Negative 5/4,
Glad it's not like 4 over 615. or whatever.
right? Or negative 27, 124, 205. Bring down the 4, which makes this one a negative 5. This one will be negative 33. Is that right? Which is, oh yeah, because math. That's good, because 33 was going to be annoying and ugly. This is going to be positive. Yep, 40. My brain agrees with the calculator. It's a happy day, 164. And then probably 2, that sounds accurate.
205.
Yep, 205 gives us 0.
Okay, so now we're left with 4x squared minus 32 plus 164.
True enough. Okay,
Can we take a photo of this?
we can.
Yeah, I was wondering if we were allowed to do that.
You are, because see what you have here is, what we actually have is this. We're finding the zeros, so we would have put 0 right here, right? And so that equals 0, so if you just divide everything by 4, then it works out just great.
Okay, so then you're left with x squared minus 8x plus 41.
Plus 41, yes. And then it does not factor, which was the issue, right? So what other option do we have? Quadratic formula, sure.
Or what's the other options?
Completing the square, so would be the other option. Opposite of B.
That would be easier.
Depends on how you feel about both.
Probably be easier if you don't know the quadratic formula.
Well, yeah, that's true. If you don't know the quadratic formula, then yeah, completing the square is what you got. So -8 here, -8 here, 1 and 41 and 1. So we got +8 plus or minus the square root of 64 minus what? Oh.
Just go over the quadratic formula.
Minus 164 all over 2. So we've got 8 plus or minus. Yeah, I was just trying to decide whether to skip a step, but I'm not going to do that. Okay, and then we end up with 8 plus or minus 10i, right, over 2.
Or 4 plus or minus 5i?
Yes. Okay, so now to answer the problem like it wants us to answer the problem, I don't have a well, this kind of like gets the rest. This, like we're kind of in the place now. F of x equals x plus 3 times x plus 5/4, which we're going to do that as 4x plus 5, right? And then x plus, no, x minus 4 plus 5i, and x minus 4 minus 5i.
Don't forget that 4 on the outside. We factored out at some point.
You don't need it,
Oh, yeah.
or do you need it? What are we doing? What are the instructions? What is the plan?
Write each function as the product of linear and irreducible quadratic factors and the product of linear factors, and then list all the zeros.
Yeah, I don't think so. Let me see. Hold on. 46. Yeah, we don't need it. And then this is ugly, so we need to clean it. Or do we? Do they clean this more than this? I don't remember. Let's find out. Let's find out, shall we?
And if we start distributing, it just gets back to the original.
Right, yes. That would be, yes. We could turn it back into the other.
Irreducible.
Oh, yeah. So for part, this is actually part, yeah. So this, what we wrote, is part B, or C. Is C, which is the,
List all the zeros.
C is list all the zeros, yeah. So this is part B, where we write it as linear ones, right? Right? So this here, you would, to clean it up, you would distribute these negatives and make it plus and minus and plus, right? So that it's not ugly. This is part B. Part A of this, for this problem, would be just f of x equals x plus 3 times 4x plus 5 times 4x squared minus 32x plus 164. Wait. Oh. Yes, this except what I actually meant to say was x squared minus 8x. I forgot we did the reduced. Plus 41.
And then, because you can't imaginary.
No, because part A, the directions for part A are rise of the product of linear and irreducible quadratic factors, right? So linear and irreducible, so the reduced quadratic factor. So this is a reduced quadratic factor, irreducible quadratic factor. And so this is part A, this is part B, and then part C would just be listing all the zeros.
How do we list those funky ones and zeros?
So you would list, so the zeros would be -3, -5/4. And I like the condensed plus or minus version. The book uses the spread out one, but I would do just like 4 plus or minus 5i. I like that better personally because it's cleaner.
So we did have to do the imaginary part, but you don't.
Right. Right. We had to do it. We had to do it to get part B and to get the part C. All that's true. You will absolutely, the numbers may not necessarily be this ugly, but you will absolutely have one of these on the test. Absolutely. Maybe even 2.
And then what was part A?
Part A was right this one. This is part A right here.
Oh.
This is A. We just went straight to B because I forgot what the instructions were. But yeah, so part B would be finishing this all out. But part A, you leave it. Once you get down to a quadratic, you can be done. Unless it's factorable further. And then you're not done. So, but since we couldn't factor it, that's that. Okay. Because of time frame and all the things, what is likely to happen for Tuesday, and this will all get put in Google Classroom. This for sure will. Is for one thing, we're gonna omit lesson 2.6.
Does that mean the test is next Thursday then?
Yeah, well, that was going to be true either way. But we're going to omit 2.6, not going to exist. What is likely to happen with rational functions is I will give you probably a combination of my videos from Algebra 2 and another guy's videos that I already know about that are really good on this topic. The notes is I'm going to leave it to your mileage may vary, and I may or may not remember to put this part in the Google Classroom. So if you want, if you watch just one of those videos and you're able to do the homework fine, then that can be your entire notes. But if you need to watch both videos and do the stuff, then that can be your notes. It's, again, review, although it's rational functions, so it's polynomials flipped over, right? And so it's pretty much review. The only difference between this and the Algebra 2 version is they're not always looking like this. Sometimes they're looking like this. And so, and even some with a little bump in the middle, but it's the same topic as in Algebra 2. And yeah, so yes. And then homework will be, I probably will do a lot. Well, I may give you a more complete homework set potentially because you're only going to do one lesson for Tuesday. So I may give you it. And this particular lesson, because it's not just reciprocal functions, it's all the rational functions. So it's the ones where you got polynomials on the top and the bottom. So you can have all the weird slant asymptotes and vertical asymptotes and horizontal asymptotes and all the weird stuff. You probably will have like a full-on homework set type thing. But the notes videos may be a little bit wonky depending on time, because I'd like y'all to have access to stuff like today instead of having to wait and whatever else. And this is going to be probably, if I have to guess and being generous based on the way this is all working out, I bet you this is 2 hours worth of video for what I will ultimately make on this lesson. So
That means like the other guy's stuff and your videos?
no, I'm just saying, like, when I make my own pre-cal version, whether I make it this weekend or in the future, it's probably 2 hours worth of content, probably. And I will, then the videos are going to be kind of, like sometimes you'll have my new videos and sometimes we'll have this. It's going to go kind of back and forth just because of the amount of time it takes to make these things. And so the test is on Thursday. Yeah.
We're gonna have homework.
Yeah, I would start studying, yes. You'll have homework due on Tuesday, but no homework due on the test day, of course. Yeah. The practice test is, if you want to start studying, that's still a great choice. So is the study guides. If you want answers to any of the practice tests or study guides or any other problems from this book that you're using to practice, just send me a message and I will send you a picture of the answers, and we'll have all the things.
And you'll make the test just like a practice test, just without the.
Usually what I do on to make the test is I go through the practice test and I'd give some amount of problems. I will attempt to make this test not grotesquely long and difficult, like that one Algebra 2 test that was actually over the same material. So I will try to. We'll have to test. We'll have to have some tests over some things, but some of the stuff may get condensed and whatever else. But I will make an effort to not make a ridiculous test. I can't promise, but I will make an effort to not make it ridiculous.
Okay.
Any other questions?
On the practice test.
Yes, sir.
We're omitting 5, 6, right?
Right.
Which problems on the practice test would we omit?
27 and 28
Okay, thank you.
on the practice test. Yeah. What is it?
I have a question about 48 that we're supposed to be doing for the homework. 'Cause
Like the new homework or the old homework? The one that was due today? Okay. 48. What is your question on 48?
Because whenever you write like the P and the Q thing, P is the final number in the line and the Q is the coefficient of the first number, right?
Mhm.
Okay, so we can only have stuff over 1 for this one, but the zeros are fractions. So how are we supposed to figure that?
What does the answer say it is? It's because of the missing terms, like probably, if or I'll explain better what I mean by that in a second. Because that's okay. Yeah. That because the answer key gives me enough to confidently answer your question. It's because that list, the plus or minus list, that only gives you the possible rational zeros, not the possible irrational or complex zeros.
How are you supposed to figure out those?
This one, that one's straight up factorable, or you can use a quadratic formula, and I'll give you enough. I'll give you enough that you'd be off to the races doing it, because we're almost out of time. But I don't think it's long to.
Do it if it's not easily factorable. Do you just do quadratic if it's not easily factorable?
Right.
It's 3 terms.
Yep. Is as long as the equation is in quadratic form, which it is. It's not a quadratic, right? But it is in quadratic form.
What do we do if it gives us one that is not in quadratic form?
it won't unless it has some rational zeros, because you don't have any methods for solving that. But the one thing that I'll mention on 48 is when you do the quadratic formula, it would be x squared equals, right? Because we'd have to do or you might even want to say, if you prefer this way of thinking about it, let u equal x squared and then u equals, right? Either way of thinking about it on this particular problem. But then you have to, there's another step after you do the quadratic formula. You'd have to then square root that and simplify that and all of that stuff.